Every rocket you see launching today, most of it never comes back. Billions of dollars are burned, literally, with every trip. But what if we could fly to orbit, deliver cargo, or even people, and then land the vehicle like a regular airplane, ready to go again? That's the promise of spaceplanes, reusable orbital launch systems that could change the future of space travel forever. For decades, space access has been ruled by rockets, but rockets are expensive, massive towers of fuel and engines designed to work only once. The Saturn V, Space Shuttle external tank, even most of today's Falcon 9 components, discarded after use. The result? Every launch costs tens to hundreds of millions of dollars. That limits how often we can go, what missions are possible, and who can afford to reach space. If humanity wants space to become as routine as air travel, we need something better. A spaceplane is exactly what it sounds like, a vehicle that can take off, reach orbit, and then glide or fly back to Earth for reuse. Instead of throwing away hardware after every mission, you refurbish and fly again. The idea isn't new. The space shuttle was humanity's first real attempt. But now, new designs are bringing the dream closer to reality, with smarter materials, advanced engines, and a sharper focus on economics. The Space Shuttle, introduced in 1981, promised airline-like reusability, but the reality fell short. Its solid rocket boosters had to be fished out of the ocean, its engines required huge overhauls, and the thermal tiles were fragile and costly to repair. Instead of quick turnarounds, each mission required months of preparation. Still, the shuttle proved something vital. A spacecraft could take off on a rocket, perform orbital missions, and then land safely, like a glider. That was a breakthrough the industry has never forgotten. So what makes building a true orbital spaceplane so hard? Speed and heat. Re-entering from orbit means hitting the atmosphere at Mach 25. Surviving that heat requires advanced thermal protection systems. Engines. To reach orbit, you need rocket performance. To take off and land, you need jet-like flexibility. Engineers are experimenting with combined cycle engines, part jet, part rocket. Weight, wings, and landing gear add mass, which makes reaching orbit harder. Designers must balance reusability with efficiency, cost versus complexity. Reuse only helps if refurbishing is cheap. Every bolt, tile, and engine cycle has to withstand repeated use. Solving these problems is like threading a needle between physics and economics. 1. Sierra Nevada Dream Chaser, a small lifting body spaceplane, designed to resupply the ISS and return experiments by landing on runways worldwide. Compact, flexible, and safer than capsules for delicate cargo. 2. China's Spaceplane, Shenlong and others, shrouded in secrecy but tested successfully, suggests a serious push for rapid turnaround military-capable spaceplanes. 3. Boeing X-37B, a mini shuttle currently operated by the U.S. Space Force, can stay in orbit for years, then glide back to a runway, likely used for testing advanced technologies in secret. 4. Future concepts. Sabre and Skylon. The UK's Sabre engine can breathe air like a jet in the atmosphere, then switch to rocket mode in space. Skylon, a single-stage to orbit design, could take off from a runway and fly directly to orbit. If it works, it could revolutionize access to space. The heart of the issue is cost. Spaceplanes promise airline-like reusability. Imagine instead of throwing away a $200 million rocket, you refuel, inspect, and fly again. Launch costs could drop from tens of millions per mission to just a few $100,000. That's the difference between space for the few and space for everyone. Scientists, companies, even tourists. Lower costs mean more satellites, more science missions, more exploration, and potentially the infrastructure for a true space economy. But spaceplanes aren't just about cheaper satellites. They could enable rapid global travel, New York to Tokyo in under 2 hours. They could ferry crews to orbital stations, build infrastructure for lunar bases, and even prepare us for Mars by making spaceflight routine. In short, they're a stepping stone to a future where space isn't rare, it's normal.